Okay, so back to our topology here. So we talked about NAT last week. We talked about the SNAT, source NAT, and destination NAT, right? Source NAT, where the source IP address gets translated, which typically is utilized when your internal resources, they try to access the internet, right? That's typically the use case where you use source NAT. Okay. In comparison, for destination NAT, that comes into play when you have someone external try to access an internal resource. Okay. And this typically would be some sort of web server that you host, maybe from a retail perspective, from e-commerce perspective. Okay. Obviously, you will not give someone on the outside access to your LAN users. Okay. So you would typically give access to any server that you might be hosting, your organization hosts. Okay. Now think of things like Facebook or Amazon. Okay. Amazon Shopping, etc. Right? So they have their servers hosted, web servers, which you can access over the internet. Okay. But you cannot access any internal resource for Amazon. Okay. Their internal portals or anything internal to them. Okay. That is typically the use case where DNAT or destination NAT would be utilized. Okay. Now, one thing from respect to port forwarding that is mentioned. So port forwarding typically is where you are translating the port as well. Okay. Or you want to redirect traffic to a different port. Okay. So for example, if I receive traffic on port 443, but I want to send this packet to my internal server over port 8443, for example. Right? So I am doing port forwarding. I am transferring the traffic or the packet from 443 to 8443. Okay, so that's what we call as port forwarding or port redirection, for example, different names for it, okay? But it does the same thing. Okay, and this is very common where a lot of time organizations have uncommon ports being utilized. Okay? So imagine an organization has, let's say, this as the web server that they host in the DMZ, right? Instead of opening port 443 for web traffic for HTTPS, they enable 8443, an uncommon port, okay, to protect against attacks, etc. Okay, because again, everyone knows if a server is running HTTPS, it would typically be listening on 443. Okay, so from a security perspective, an organization can choose to not use 443, but instead use an uncommon port, which would kind of become very difficult for an attacker to guess, for example. Okay, so so this port I keep as open and I close port 443 on the server. Okay, now if you are a user sitting on the internet and you want to access this web server, you would typically access it over port 443 because obviously you don't know, or your browser won't know that this server is operating on 8443 instead of 443. Okay? Now, when you send this packet, okay, now the firewall would know, obviously, that any packet that is meant for this IP address, for example, needs to have the port translated from 443 to 8443. So before the firewall will send a packet, it will translate the destination port. So this would be the destination port in the packet. So this port will be translated 443 to 8443 before the firewall sends or redirects this packet. Okay, so that's called as port forwarding. Or port redirection. Okay, same thing, different name. Okay, right? Hope that explains port forwarding
Yes,
piece.
sir. Clear.
Okay. Now we'll first implement in our lab, we'll see how SourceNet gets implemented. Okay, and then we'll test internet access from all of these. Okay, previously we defined security policies on our firewall. Okay, so should be able to access the internet. Okay, now we're going to be implementing SourceNet or SNet. Okay, from Palo Alto's perspective, sometimes you would see the word outbound NAT mentioned as well. It's the same thing. Okay, different names. Okay, SourceNet or outbound NAT. Okay, name is very intuitive. It will become very easy for you to understand and remember. Right? When you are sending outbound traffic from your LAN to the internet or from your internal network to the internet, that's outbound traffic. You want to do NAT for it, so that is going to be outbound NAT or source NAT. Okay. So when you define a NAT policy on a Palo Alto firewall, you basically define the source zone and the destination zone, obviously. Okay. So for example, in this case, we will define a couple of different NAT policies. Okay, because our source zone could be any of these, and our DMZ zone, and our destination would be the WAN zone that we have. Okay, and what we will translate it into would be whatever we defined as the destination zone. Okay, so whatever we define as the destination zone, there will be an interface that is attached to that zone. We've already defined our zones and attached them to interfaces. Okay, whatever that interface IP address is. Okay, so this outside interface typically will already have a public address. In our case, we are configuring a public address in production as well. You would have some sort of a public address on that WAN facing interface. So all the traffic that originates inside our network, we want all of that to be translated to that IP address, that outside IP address. Okay, so that's how we will define our source NAT. Okay? And we will be defining it as a dynamic NAT or a PAT so that we don't have to do one-to-one mapping. All right. So let's come into our firewall. And last time we defined lots of different policies here. Okay, so that our VLAN 20, VLAN 30, our DNS server can access the internet. Okay, and our internal resources can access our internal server as well. Or DMZ can access the internet as well. But right now, since we don't have that, none of these are able to access the internet, even though the policy rules here allow that traffic. Okay. So under policy, under security, we have NAT. So this is where we will define our NAT policies. Okay, so let's test our NAT configuration, or let's create our NAT policy. Okay, and we will define it for our LAN network and our DMZ network to be able to access the internet. Okay, so click on Add, and we'll give it a name. We will call this inside. Again, name can be anything to internet. Okay, but always ensure that it is very intuitive. It is very easy to read. Okay, if you maybe give the firewall to someone else, and if he has to look at the policies, he can instantly tell or instantly figure out what the policies or why the policies were created. And you can add a description as well. So I could add something like translates traffic from LAN and DMZ to outbound, or I could say to WAN, for example. Okay. We'll go into original packet. Now the source zone. Okay. I'll add, right? So this is where whatever objects and everything that we have created previously, they help. Okay. So anytime traffic originates from our LAN flags PC or our Win PC or our server or our DMZ. Okay, so I have defined all of my internal network in this single rule. And the destination zone is going to be the WAN P or primary. Okay, if you want, instead of having this set to any, I could also define the source addresses. I could say tags Win11 PC for our DMZ servers. We'll define our address group that we configured. Okay, so this is going to be a source. How do we want to do the translation? So under the translated packet, this is where we will choose what sort of a source NAT we want to do. Okay, so we want to do static, we want to just do dynamic, or we want to do dynamic IP and port. This is the band. Okay, and what do we want to translate the source address to? Okay, I could define an IP address, or I could define an interface address, right? So I told you that typically in production as well, the WAN-facing interfaces have public IP addresses. Any traffic that originates internal, we want them to be translated to that WAN IP address that is already configured on the interface. Okay, so that's what I'm doing here. I'm saying interface address, and then I'll choose the interface. In this case, we're gonna choose that Ethernet 1.1, right? That is the primary WAN. And it will automatically show me the IP address that's configured on that interface. Okay, so this is what my translated packet will look like. The original packet will have a source IP address in any of these subnets that we have defined. A translated packet will replace those source addresses to this IP address at any time the traffic goes through that interface, which in our case is that primary interface for WAN that we have. Okay. So this is now what it looks like. Now, in our case, we have two WAN networks. Okay. So currently, if you remember, we have path monitoring enabled, right? Which is sending the traffic through this interface currently, the primary. Okay. What if this fails? In that case, the traffic will then be sent over this standby. Okay, so we will also need to configure a second NAT statement. Okay, because here this is Ethernet 1.1. In the second one, we would need to define Ethernet 1.2, which will take effect only when the primary interface goes down or that primary link goes down. Okay, so I could change this to and say WAN primary. Okay, and I could say this internet P primary as well. Okay, now everything in this will typically remain the same. So rather than configuring everything again, I could just select this and clone this rule. And I could change this as well if need be. Okay, or if you want, I could create a new one. Let's just clone this. Okay, click on OK. This is the second rule that I created. So this is P, this is created as P-1. We will come in here and we will say S for secondary, then WAN, we'll say backup. Everything remains the same. Nothing changes in the original packet, but in the translation packet, we will change that interface to E12 this time. And click on OK. So now we have defined two different NAT rules. This one will be used as long as our primary WAN interface is active. When the primary WAN interface goes down, because of path monitoring, the traffic will then start flowing through Ethernet 1/2. When Ethernet 1/2 interface becomes active, we already have a NAT statement for that. Okay? So you basically need to consider both the options because you have two WAN links. If let's say a production environment has 3 or 4 WAN links for whatever reason, you would need to define those many NAT statements. If you have just one WAN network, then you only need to define a single NAT state. Okay, right? Let's go ahead and commit this. And once it's committed, we will then go ahead and test our internet connectivity through these PCs that we have, okay? Making sure that we have connectivity now, internet reachability. We are able to access different websites, etc. Okay, so let's give it a moment. It's very easy to set up NAT as long as you understand the concept of NAT, right? Why you're doing NAT and what you would be translating with NAT. It is very simple. Okay, it's very straightforward, right? All of these objects and everything we already created last week. Okay. One error that I did here, I did not change the destination zone. Okay. So I should have changed the destination zone to the WAN S, right? So this security zone is attached to the 1/2 interface. Okay, so it's very easy to miss small things. Okay? But again, as long as you understand, and that's why the names are very important. Okay, so if I had not written these as WAN P and WAN S, I would not really be able to tell the difference which WAN interface I am referencing to. Okay? Because you're not going to go back and forth between different configuration sections, right? So you're not going to go back to network and go back into zone and see which interface is connected to which one. Okay, And you can see here that we have V1S here. Okay. So I don't want to go back and forth in objects under network, etc. to every single time see what interfaces bind to which. Okay. The names should be self-explanatory for me. Okay. Let this finish. Let's see how much it has. 99. And then we'll go ahead and test our internet reachability. Okay. So let's open this PC first. We had already configured IP address on it. So let's look at Net Manager. And we already have that. Let's look at properties. And we have, oh, okay. So one more thing. We have not defined static IP addresses, right? If you remember, we wanted to do DHCP as well. Okay, so let me just log in and let's verify that. Okay, let's see here. This Ethernet interface should be set up for DHCP. Okay, so we left it at DHCP. We only defined static IP address on these servers and the DNS, but I left it because I wanted to show you how you can set up DHCP server on your firewall as well. Okay, in small locations, in small environments, deployments can choose to have the DHCP server on the firewall itself rather than implementing another different server, a Windows server or something like that. Okay, so it's very easy for you to set up a DHCP server as well. Okay, so we'll go ahead and set up the DHCP server real quick. Okay, so you can see how DHCP works. And then these will receive an IP address in their respective networks. So I will, rather than saying this as 2, I'll give it a /0. Okay, so that they can receive any IP address in those respective subnets. Okay, and in addition to providing an IP address, it can also provide things like DNS and a whole bunch of other options. Okay, so let's go into device here. And oh, sorry, we need to go into network. And here we have an option for DHCP. Okay, so you can see we can define a DHCP server here. Click on add. And it will ask me on what interface I want to enable the DHCP. So I want to enable it first on the .20. This is the sub interface for our VLAN 20, and we have 3.30 for our VLAN 30. Okay, so we need to do 2 DHCP servers since we have a sub interface. We'll first do for .20. Okay, we'll leave the mode as auto, and then we will define our pool. We'll define our lease. Okay, so I'll click on add, and then I will say 10, 0, 20 dot. Let's say we want to give an IP address in the range 90 to 99. Okay, and I entered this incorrectly because I wanted to show you how the firewall gives error as well. Okay, so you can see anytime there is something incorrect that you have entered, you're going to see this red line beneath it. Okay, it basically means that I entered the configuration incorrectly. Okay, and if you bring your mouse here, it will say invalid IP address or invalid IP address range. Now, how do you figure out how do you enter the correct range? You delete this, it tells you how exactly to do the configuration. Okay, so you can set it as a subnet if you want to give out the whole /254. Okay, you can subnet it if you want, or you can, if you just want a particular range, you can give it that way. So basically, I don't have to do any space. Okay, let's try that again. This time I would say 10.0.20.90 to 10.0.20.99. Okay, now I don't get that red line. Okay, so it basically means now I don't have the error. Okay, and if I come over here, it will not give me any errors any. Okay, so always look out for those key items that the firewall will give you to show you that you are entering the configuration incorrectly. Okay, so this is going to be the range in which this device will receive an IP address. Okay, I could have defined it this way as well. Okay, and then I could have defined the reserved IP addressing. Okay, so maybe the .1 is assigned to the firewall, .254 is maybe on the gateway. So I could have defined reservations as well. Those IP addresses will not be given out as part of the DHCP. Okay, so I'm pretty sure everyone knows how DHCP works and everything. Okay, so all of the concepts apply as it is. Okay, so I'll define it this way, right? You can choose to lease the IP address for unlimited time, or you can set a timer. Okay, so for example, I'll set this or I'll leave this at the default of 1 day. Okay, so in 1 day, the lease will time out and the client will have to reinitiate DHCP. Okay, another option, which is very nice here, is to enable this ping IP when allocating new IP address. So before the firewall will lease out an IP address, it will ping that IP address to make sure that IP address is unique and is not being used anywhere else in the environment. So this is to prevent any sort of IP address duplication or any IP conflicts. Okay. In addition to this, you can also choose to give out other options. Okay. So for example, obviously, I would give out a gateway. So the gateway is going to be 20.1. This is the IP address on the 1/3.20 interface. That will be the gateway. And the subnet mask is obviously going to be /24. Right? The primary DNS is obviously I can define what the primary DNS would be. In our case, it would be 10.0.40.3. Right? And I could define a secondary DNS as well. I could define Win server as well. I could define NTP server as well. I could define if we are doing any mail or anything. So if you're doing POP3 or SMTP, we could do that as well. Okay. if there are any additional custom options that we want to give out, we can define it from here. Okay, so for example, if there are any IP phones in the network, right? The IP phones require TFTP server IP address, which I can provide through option 125. Okay, so we can define custom options within DHCP as well. For now, these are the only settings that we would need: DNS, subnet mask, gateway, and IP address in this range. The IP address will be leased out for a period of 24 hours or 1 day. Okay, I could also set this to 0 days and 23 hours, for example, 23, 55, something like that. Okay, so at the 1 day mark or at the 24-hour mark, lease would need to be renewed. Okay, and before the firewall provides the IP address, it would ping that IP address to make sure it's a unique IP. Okay, another configuration that I didn't talk about is this mode. This is very clever. Okay, so there are 3 different modes here: auto, enabled, disabled. Enabled basically means that the DHCP server will always be on this firewall. Disabled obviously means it will be disabled. DHCP server will be inactive on the firewall. The default is auto. What auto means is the firewall will try to see if there is any other server on the network, DHCP server. If there is, it will deactivate itself so that to avoid any conflict on the network. Okay, so this is very clever from the Palo Alto firewall. Okay, it will poll on the networks. For example, on this network, on this 1/3.20 network, it will poll and try to see if there is any existing DHCP server as well. If it finds it, it will deactivate itself. It will itself not serve as a DHCP server. Okay, so that's why it's always a good idea to leave this at the default mode of auto. Okay, so I'm happy with these settings. I'm going to go ahead and click on OK. All right, so you can see all the details right from here. Okay, and once we commit this, we have these devices get IP address. We can then come into this view allocation and we will be able to see what IP addresses were allocated to which devices as well. Okay, so let's quickly set up the other one as well for this VLAN 30. Right now we did it for .20. 30, we're going to do almost the same thing. Timeout, we will set this to, let's say we'll set this to 2 days for this network. The pool is going to be 10, 0, 30, and I'm going to change the IP address a little bit. Okay, so this time I'm going to say 190 to 199. That's going to be my pool of addresses that I will provide to this network. Under options, I will define my gateway, which is going to be 10.0.30.1. Again, the IP address on the firewall itself, it will act as the default gateway. That's subnet mask, and my DNS is 40. Click on OK. Okay, so you basically enable DHCP server on a per interface basis, not completely on the firewall. Okay, and typically you would only enable DHCP on your internal network, on your inside network. Okay, typically your LAN only. Okay, go ahead and commit these changes. And we will come into our firewall, and it's currently disconnected. So when this is done, I will go ahead and connect this so that it goes ahead and does a DORA, does a DHCP. Okay. Similarly here, I will come into the adapter options, and we'll probably just try and renew the IP address. Just do a query to the CLI. Just wait. Almost done. Great. Okay, so come in here, I would say ipconfig/renew. So this will have it do DHCP. And you can see it received an IP address, 10.030.190. That's gateway. And I could do an all here, and we can see that it also received the DNS server. Similarly, on the Slacks, I'm going to click on connect. And you can see at the bottom, it also received an IP address, 20.90. Let's look at properties. Obviously, we are still doing DHCP, so we won't see anything there. Okay. Let's come back into our firewall and see the allocation. You can see the MAC address. That's a Windows 11 PC. You can see that name. Okay. That's the IP address that it has given out. That is the MAC address for this PC. Okay. Similarly for the other one, .90, given the IP address. So you can see it has given out one IP out of the 10 of the pool that we defined. So 10% of the pool is being utilized. Okay, so that's how you set up your DHCP server. And now that where we have the DHCP server, okay, let's see and test if something like internet works or not. So here, I'm going to open up the browser. Okay, let's try to do something like google.com. Okay, and taken the fact that our firewall, right? So the way that the flow is for traffic, this is the DNS server. He's trying to do google.com. Okay, you can see it's not reaching. So he will send a query through the firewall to the DNS server. The DNS server will resolve it. And then he should be able to access the internet. Right? That's a flow. That's the way that we have set up our flow. If things are not working, that's when you look at logs. Okay? That's where you do the troubleshooting. So if you come back into the firewall, oh, let's come into monitor. Okay, and you can see here. That LAN slacks PC trying to talk to the LAN server. That's the source address. That's the destination address. You can see the application. It's DNS port 53. Right? And it's allowed. So as per our policies, this part is working fine. But if you're going to notice, when this LAN server, okay, the 10.040.3, it tries to go over the WAN. The traffic is being denied. Okay, you can see policy denied. So the server is himself not able to reach out to the DNS. So that's why it is not able to provide the resolution to the LAN piece here. That's why the internet is not working. Okay, so very important for you to be able to figure things out through the logs. Very important are the logs. Let's see why this is not working. So let's come into our DNS server first. Okay, and let's see, how is the server set up? Okay, you can see I'm not able to access it. It could be a problem with this virtual server as well. Okay, so it's not coming up, it's not working. So let me power it off and let's power it on again. Okay, so if sometimes when you are doing your labs as well in the pods, in the racks, if something like this happens, do a shut, do a power off and a power on. You do a start stop this way. Okay. Okay, let's go in here and
What
let's
we
see.
will check here, Arun? What specific thing we will check?
I want to just check the DNS. How is the DNS set up on this? And then we'll check the policies. Why is the policy not allowing the traffic? Because if you're going to notice one thing, this server is trying to do DNS over the WAN to these different IP addresses.
Yes.
Okay, so they might not be DNSs, first thing. If you look at our policies, in our policies, in our security policy, we defined a rule to which we are providing internet access to our internal DNS server. Okay.
Yes.
But the destination IP address is this group, which
Yes.
basically is these two IP addresses only.
Correct.
Okay. So we need to check how is the DNS server set up, because the DNS server is not sending requests to any of these IP addresses. Because of which the rule that the firewall is selecting is this interzone default, which is set to deny. Okay, so that's why it
Okay.
is denying that traffic. So you can see here, interzone default. It's a policy deny. Okay, and you can see it's not reaching any of those IP address. Okay, but if you're going to see at the bottom here, it does send a couple of requests to that IP address. And you can see it's being allowed because of that internal DNS to internet rule that I just showed you in the policy. Okay, so it is sending some of these requests, but then it is also sending a lot of these requests to these random DNS servers,
Okay.
which it should not.
Okay.
All right, so we'll just verify how the DNS server is set up, really. So let's come in here. We have the DNS server set up. Let's check the IP addressing first. Let's check that interface first. This is set up with static, so okay, so it's defined with that 422.888. That part is okay. Let's look at DNS. Look at the property, forwarders. Okay, that's the reason that it's not able to resolve. So what really happens in production DNS really? They're going to send requests to this DNS server, and then this DNS server should send and try to resolve the request from a public DNS. Okay, so this DNS server does forwarding of the requests on behalf of your internal devices. Okay, so right now, the way that I see it, not set up for any forwarders. Okay, and you can see the purpose of the forwarders. It is configured so that the server can resolve DNS queries. Okay, so obviously, this DNS server does not know about google.com or who google.com is. Okay, so it needs to reach out to google.com or a public DNS which knows about Google. Okay, so I will configure a couple of forwarders here. So we'll say 4.2.2.2 itself and 8.8.8.8. Okay, so I'll set it up this way. Or if you would have made this DNS server as a domain controller, it would have automatically configured the forwarders. Okay. Now, typically, it should be able to resolve these. And, we should be able to see Google appearing here. But since it's unable to resolve this, which tells me that this server itself is also not able to access the internet. Okay, and it could be a lot of different reasons, NAT not working, policy not working correctly. Okay, so let's check the policies again. Let's refresh. And this is our LAN server trying to send requests to these 422.888 IP address. Okay, and the policy is allowing it. It's matching that correct rule that we have configured, the internal DNS to internet. And it's aging out. Okay, so nothing on the firewall is blocking it. Let's look at some details about this. Okay, so you can click on this and it will give you more details. Okay. So right now it is trying to go out this WAN standby instead, which has the Ethernet 1.1 interface. And I want to see if NATing is working. So NAT is happening as well. So you can see This is the original source IP and source port. This is being NATed to the IP address of this interface, and the port as well is being NATed. So this is where PAT is happening, or dynamic NAT is happening. Okay, so NATing and everything is working fine. Okay, but this is the concerning thing. Okay, so I think
it should work on a WAN primary or
correct, right?
right?
Because the WAN primary is the active interface,
Exactly.
right? So I think the way that we set up our zones and everything, we set it up incorrectly. Okay, so logs give you a lot of information. Okay, and that's really your basis for troubleshooting. Okay, so you should understand, and then based on the logs, you typically should do kind of like a re-engineer or reverse engineering in your mind. Okay, I'm seeing WAN. That's why the names are important. Okay, so you can see, right, by looking at this name, I know that this is now going through the standby interface, which is currently not an active route. Okay, so let's trace back and let's go into our network here. Zones. Let me first look at our route. So let's go into virtual router first. And we have this VR01. Okay. Let's go into the runtime stats. Let's go into static route monitoring. Okay. And E11 is interface here. If you look at the forwarding table, E11 should be the interface through which our packet should go out. Okay. If you look at our log here, it is going out through E11 itself, but we have the zones configured incorrectly. Okay, and you can see it's currently natting it incorrectly as well, just because of that zone configured incorrectly. Okay, so this interface should have a WAN P as the zone rather than a WAN S. Okay, so now it's because the firewall is figuring out the zone, and then based upon the zone, it is also checking the policy as well as doing the NAT. Okay, so let's come into our network. And these are very common misses and common misconfigurations that you can do. Come into zones, and we have P assigned to 1, 2, S assigned to 1, 1. This needs to be reversed. So WAN P, I will delete this and add OR. So it won't show me 1, 1 because the 1, 1 is already attached to a different zone. One interface can be assigned to only one zone. Okay. So let me just
You need to delete one policy.
And without saving an interface, it won't allow me to save this as well. So I will just come in here and do 1, 3 here. Okay. It won't allow me to do that as well. So let's do 1, 3. I'm just doing it just to save this. Come in here. This is where I will define 1, 2 instead. Okay. Go back into the P, define 1, 1 this time here. Okay, so my WAN P should have 1, 1, WAN S should have 1/2. This is now correct. Coming into our policies, our security policy. This is here, and you can see both the zones were defined. And here, okay, but the NAT was functioning incorrectly because an incorrect IP address was being provided or translated to. Okay, so it should be getting translated to the primary because the primary root is enabled. Okay, let's do a commit and see if this fixes the problem. So a lot of times the issue is going to be a very small thing. Okay, just like here, it was just reason for the incorrect zone being applied to the incorrect interface. That's really it. Okay. Nothing too major, but it was causing a lot of unwanted behavior. Okay, so if this would have been just a single WAN interface, we won't have faced those problems, right? But I created the topology in such a way because a lot of times in production, you would have multiple WANs, multiple ISPs. So that is done. Come into monitor. Let's see if here, right now it's assigning that correct interface. Previously it was doing WAN S. Now it's doing WAN P. Okay, and now you can see the IP address is being NATed correctly as well. And you can see this is the original source port, and then this is the PAT or the port translation that is happening. Right. So let's come into our DNS and let's come into properties, forwarders.
Empty.
Okay, so it is able to resolve this now. Okay, so which basically tells me that now this server has internet reachability. Come into Slacks here and you can see Google now working. Okay, let's try some other website from here. Let's try YouTube, for example. Okay, YouTube works, that's fine. It's a very old PC, so that's why you're getting this. Let's try something else. Let's try Facebook, some of the more common websites that LAN users will typically use. Okay, let's come into our Windows 11. This is a more modern PC. Let's try with this guy here. Okay, but since it's working there, it should work here as well. Okay. And if you look at the logs now, we should have the LAN able to access these websites, and you can see the firewall is recognizing the applications as well. This is the application identification or app ID, application visibility. Okay, you can see down below, it also recognized Google, and you can see the ports. Okay, some of these applications are coming out as incomplete. That's fine. Okay. Okay, so the application visibility function is also working fine now. Okay, and we'll talk about application visibility, app ID. I'll spend a good amount of time on the app ID because it is a very crucial, a very critical component or part of the next generation firewall. Okay, but you can see it working absolutely fine now. Okay,
I have one question.
Yes.
In the session and reason, they have showing TCP reset from client.
Right.
All right.
Right.
Okay. So
Once that
reset
session,
means like, okay.
once that session has been established, right, there's nothing really
Okay.
happening right now, right? So this page got loaded, the data got loaded, etc. Okay. So the firewall has received a TCP reset from the client PC. Okay, that's why it ended this session. Now, when this user will kind of come in here, log in, or do anything else in here, a new TCP session will be established. Okay, so TCP
So when the
sessions, so TCP
session close,
sessions, they are not kept active for unlimited periods of time, right? They time out. So either they
yes.
time out if responses don't come back, or they time out when either the server sends a reset, the client sends a reset, etc. Okay,
Okay.
so these are typically very common reasons that you would see. Okay, TCP reset either from server or either from client. And in that particular session, if more activity happens, you would see more logs coming in here for those new sessions that will be created. Okay, so now our security policies are working. Our NAT policies are working fine as well, because this DNS server is able to talk to the internet. These PCs are able to talk to the internet as well. So our DNS is, or our NAT is working fine as well. And we can see that as well. So if you go into your policies and security, okay, so for all of these policies, you can see the hit counts as well. Okay, so you can see this policy was hit 13,000 times. Okay, you can see this rule here. This has not seen any hits. So the firewall has not used this recently. All the other policy rules have been utilized by the firewall. Similarly, if you take a look at NAT, our NAT policy has seen hits as well. 305 here, 2014 here. When was the last hit seen? When was the first hit seen? And this is just the matching counters. Okay, so when I say hit counts, these are matching counters. How many times has the firewall matched a particular rule? So every single thing, every single policy, every single rule that you would see in the firewall will have hit counts. It helps to do management. So for example, if this rule here does not see any hits in production, okay, I typically can remove this rule completely to clean up the firewall, okay, because my production is working fine. Users are able to access the internet. Everything is working fine. No one is doing any complaints about it. So it could be that this rule is a little, or it was created, maybe an extra rule or something. Okay, so from time to time, when you would do the maintenance, when you would do the cleanup of the configurations, these hit counts really help. Okay, maybe a particular rule that you see, maybe you see this rule having 13,000 hits, but this rule has not been hit recently for the past 2 weeks, for example. That's why you have these timers. When was the last hit seen? When was the first hit seen? So through this, you are able to also see the time, the date, and everything. Okay, so this helps to do cleanup. And obviously, this rule is not doing anything because the DMZ server have not initiated any internet-based traffic. Okay, this rule is for DMZ to internet. That's why. Okay, so in a moment I'll show you how you can set up for your lab. In your lab, you can set up web pages and web server. Okay, very simple. Okay. So that we can then test our destination NAT as well, and we are also able to send some traffic to these servers. Okay, so that's your source NAT. That's how you do the configuration. That's how the source NAT works. That's how you can check your NATs. as well. And we've also seen how you can set up a DHCP server on your firewall to provide IP addresses dynamically to your internal networks, internal hosts, really, or clients. Okay, questions, anyone? Okay, let's do a break. Okay, let's do a 10-minute break. We'll come back, we'll set up the web servers correctly, and then we'll test the destination NAT and see how that
Oh,
works. All right. Let's get back into this. Share again. All right. So now that we have seen static NAT, or source NAT, really, okay, DHCP, etc. Let's also test with destination NAT so that you guys can see what it looks like and what the configuration will look like for destination NAT. But first thing, what we will do is we will set up a web page on here. We'll set up website on here. I'll set up for one of these servers, okay? Obviously, I'll go through the commands and everything, and then I'll paste the commands in the Discord server so that you guys can save it if you want to set something on your own lab, or when you do access the pods, when you get to set up there, the web server, you can use those commands to set it up, okay? It's a Linux-based server, okay? So bear with me if you guys don't know Linux, then it can appear a little daunting, okay? But very quickly, I'll try and explain what the commands are really doing, okay? But if it does not really make sense, then don't worry, okay? Just run the commands, watch the video, just set it up the way that I'm doing, okay? It really does not matter too much. So let's come into the server first so that we can set it up. And we come into this control panel here. Network, let's just verify if the IP addressing. So someone was mentioning in the lab that the IP address keeps going away. So you can see this server here in the lab, it keeps going away as well for me, okay? So very common for this to happen in these virtual labs, okay? So don't need to worry, it does not take a lot of time to set it up either, okay? Okay, so we are doing this on server 1, but eventually you would typically have it done on both the servers so that you can do as much testing as you want. 10.0, 4.2, is the firewall 254? Yeah, the firewall is 254, so this is okay. Name server is good. And we'll hit on apply. So that's why we were not seeing any what I was saying. That's why we're not seeing any web traffic from these DMZ servers in our firewall because it did not have any IP address. Okay. All right, so this is done. And for some reason, my PC has slowed down a lot.
Just a quick question, Arun. Is the broadcast IP was correct? Was it 255?
Right, so /24 in that subnet, 255 will be the broadcast. Right.
All right, yeah, gotcha.
I mean, yeah, correct me. I mean, I'm kind of old for subnetting, to be honest. Okay, so it lost the IP address again. Just a second, let me see. Let me do it from the CLI. And don't worry, I'll paste these commands in the Discord, okay? So sudo ifconfig, this is just me configuring the Ethernet interface that's connected. 10.0, 4.2, yep. And the mask needs to be 255.255.0, and then we add the default gateway. So sudo route add default gateway 10.04.254. Okay, so it should be able to ping 4.254. Not sure if we enabled. So I think the interfaces have the management profiles that we created in the very beginning, and I think they don't allow the pings. So I'm kind of guessing it to be that way. Sudo default gateway. It says the file exists, so it should already be there. And then we'll go into this resolve conf. This will have my DNS server, so you can see the name server is already there. That's okay. I believe this should have internet reachability because we're gonna download a couple of things. So TCE load WI BusyBox. That is just an open source, very lightweight HTTP kind of a package. Okay, and obviously, when you are doing it in your lab, this server would now go out to the internet, download that. Okay, so obviously you should have policies, DNS, NAT, source net, everything working just like we have in our case. Okay, so hopefully he should be able to download. Yes, it is able to. So it was able to download it. Okay, so my internet. So again, from DNS server now, my internet is working, source net is working, and the policies are working absolutely fine. Okay, so a lot of these things are a confirmation that those things are working fine as well. Okay. If someone is adventurous enough and they need to enable SSH on it, then you can also download the OpenSSH package for that. Okay, it seems to be a little big than HTTP. Okay.
Arun, what
And then
kind of
once
package is it?
it's an HTTP package and an SSH package. So why I'm saying package is everything in Linux is basically called a package. Okay, so for example, if you would execute something in Windows, it would be an MSI file or a DLL file or an exe file, right? We call them executables, right? In case of Linux, most of the things are available as a package, as an archive. Okay, so for example, this is a .tcz format. Okay, so all the necessary files or all the necessary components that it needs to run HTTP, it's in this package. Okay, and the good thing about Linux is when you download the package, the operating system knows already what to do with it, really. So I don't really need to tell it that unpackage this, do that. It will already work with it as long as it understands, obviously, the package. Okay, something like you don't need to tell Windows to execute an executable. You just double click and then it runs, right? And then the executable has everything inside of it, right? Same way here. Okay, so with so in the Linux world, we typically called a package, and I kind of work a lot with Linux as well, so that's why I kind of have that habit of calling Linux out as well. Okay. I will set the password. Okay, let's skip that. Don't need that. And we'll set up now a web page. So I'll go into this directory that we have, user local httpd bin. And this directory is created because we downloaded the HTTP package. Okay, that's how this directory was created. And inside of this directory, basically have our web page already there. Okay, so I will enable port 80 on this. And then even if you just enable port 80, you can still do 443 because it gets its own self-signed certificate, etc. Okay. So I'll say sudo busybox HTTPD, and the port that I want to run is port 80. And page is going to be, and this is going to be its location, etc. Okay, and we will now create our web page. So I'm going to say index.html, and then I'm going to write some text here. And yeah, one more thing. So the VI that I'm using, this is a text editor. Okay, so in Linux, anytime you have to create any files, you have to write into some files. You cannot just, obviously since it does not have a page, right? It does not have an interface really. So I cannot just go ahead, create text document and do the things, okay? So here what I'm doing is I am creating an index.html, and then I'm using the VI tool to basically edit that file, okay? So when I do this, it comes in here where I can press I. And when I press I, you're going to see at the bottom here, this would change to, it didn't change to anything, but when you do an I, after that, you are able to type whatever you need to in this file, okay? So I'll create a web page, very simple, and I will say this is the server one web server, or I could say something like, you have reached server. Okay, add something like that. I mean, play around with it, right? You can write whatever you want in it. Okay, enjoy your stay, whatever. Okay. Now, when you have added this, you need to now save it, save the file. Okay, save this file and write to the file as well. Okay, so what you do is you're going to do escape, do a colon, and keep looking at this left bottom corner. Okay, so first escape, then colon, W, and Q. Okay, so this basically means write and quit. So when I enter this, I now come back out of the file, and now that file has been created and has been written, or whatever we wrote has been written to it. So you can see we now have this file. And if I do something like a cat index.html, this will actually be allow me to view the file. Okay, so you can see whatever we wrote in the file is now saved and it's created. Okay, so escape colon WQ, right? Write and quit. That's what the WQ means. We will now create our website. So mkdir is basically make directory. So we are creating a directory. In Windows terms, we are creating a folder basically. And the path is mnt www site. And this file that we have created, all we need to do is just move this file from this location to this location. Okay, so we are going to do a copy. The CP is copy. And that location, so user local HTTPD bin, and the file is index.html that we just created. So this is the source location, and then I'm going to now enter the destination location, which is this, what we have just created. And I created an incorrect directory here. So let me do a remove. Okay, I'm going to create it again. I missed one directory. So mnt sda and www site. Oh, so I think I removed the entire directory. That is not good. mnt sda. Oh, it has, okay, SDA1. So let's do mkdir, mnt, SDA1, www site, sudo. Okay, so you should now have that. And I will just go ahead and do a copy of, when you're trying to set it up, just follow the commands, okay? And you would be able to create it. If not, just reach out in the Discord and I'll help you if you face any problems. mnt sda1, www site, and HTML, index.html, sorry. Okay, so that is done, really. Okay. Now, when you're doing it virtually, when you kind of power off the server, you will kind of lose all of these settings. Okay, so technically you don't want that. Okay, so I'm going to edit another file by using that sudo vi so that the changes basically remain persistent. So there is a boot local file on here. Okay, and to this file, I'll make some changes, right? So right now, if you're going to see, I will go in here, hit I, so that I can start typing, and then I'll add some of the commands that I already entered. So for example, the IP address configuration that I did, I will add that here. Okay, the route that I added, I'll add here in this file. Okay, so every time this server loads or boots up, it reads from this file. Okay, so I'm just adding all that configuration in this file so that it can fetch it anytime it runs. And then we will do that copy again so that it does that automatically.
Sorry, Arun. I'm just trying to understand what do you try to create? It's become a bit puzzled.
Just a simple web page, a web server.
Okay, so there's going to be a GUI or something that we can see, or it's going to be all writing?
This is just a setup. Obviously, when you would access this IP address over port 80 or 443, you'll actually see whatever we wrote in that file, the index.html.
Okay.
Okay. So sorry if it's confusing.
But... No, it's all right. I'm familiar with a few of the command suite and other stuff, but I'm just want to see what's going on. Is it going to be any outcome or is it going to be all writing? So yeah.
No, just the setup to get that up. If anyone feels this is too much, I'll probably change the servers in your pods to just a Windows server. Okay, and you can enable.
That's fine. Handy.
And then you guys can really enable IIS on there, and then it would kind of serve the same purpose. But I kind of just feel this is much easier to do.
Okay.
No, that's why I said just ignore the commands, really. I'll provide the commands so that you guys can just copy paste or just, do with it, really.
No, that kind of makes sense, though. But it just don't understand, because to be honest, I never created any website, so it's kind of like complexing my thought process. Anyway, but that's fine. You said there's something coming up. I'm really waiting for that to see. Thank you.
All right, so that's what we were setting up, right? So we now have a website that's running on this server, right? And now if we try to access this IP address over or to any of these PCs, right? As long as it's allowing that traffic, we should be able to access the web page. Okay, so let's just test it real quick. So this is working from this PC itself. We can see that we now have that web page up here. Let me come into our firewall, and in our firewall, we currently don't have any rules that allow our internal users to access the DMZ servers. Okay, so I'll quickly go ahead and add a rule here so that we can test it and make sure that it kind of works. So I'll say internal to DMZ, our source zone, just like we did the policies previously. We'll just do the Slacks PC and the Windows PC that we have. I'll add the source addresses here just to be as specific as possible. And then in the destination, this is going to be the DMZ zone where we will be heading to. The destination address is obviously going to be the DMZ server. We're going to just use that group so that both the IP addresses are covered. And for now, I'll leave the application, everything as it is. The action is going to be allow, log at session end, hit OK here. And we have this rule added. I would select this and I'll move it to the top. So I'll click on move here and move top. So it will instantly just cause that rule to instantly jump to the top. Okay, so very handy, this move tool that's there. Let's quickly commit it and then test, make sure that our web server is accessible over our network and through our firewall. Okay, and then if it is, then we would set up a destination NAT so that this user that we have, he can access that web server over, simulate some sort of a user sitting on the internet and be able to access that web server. Okay, so you will be able to see how the destination NAT kind of comes into play. Okay, that's done. Let's quickly test from here. And I'll say 10.0, 4.2. Cool. Okay, so we have a working website and a web server that we can now use to do a lot of other testing that we really need. Okay, and I should be able to access it over HTTPS as well. Okay, oh, does not work over HTTPS. Anyways, never mind, just port 80. And then we should be able to look at our logs as well, just to make sure that the correct rule and everything is being utilized. You can see right there. Okay, reaching out to a destination over port 443, that was refused. That's why you see that as an incomplete. Okay, and then we should be able to see some 80 traffic as well. It's right here. Okay, and you can see that the firewall was able to recognize this port 80 as a web browsing application. All right, so that's really was the use for giving that server 5 minutes and setting it up, okay? And you probably have that information now if, again, anytime you have wanted to test some web traffic, some testing internally in your lab, and we're not able to figure out how to set up a web page or a quick web server website, then this is the best way. And it's a very lightweight machine, the tiny core Linux that you have. So, I mean, it hardly takes about 512 megabytes of RAM, and it lightweight. So that's the reason that I kind of like to use it for these kind of lab-based testing as well. Right? Make sense? Any questions? Probably. All right. Okay.
There will be a lot of questions after you try this at home.
Sorry. Sorry.
Sure. There will be a lot of questions after we tried it at home.
Oh, okay. Yeah. Yep. Sure. Absolutely. I mean, you should. If you don't have the questions, then yeah. I mean, I'd be surprised. It's the first time you're doing stuff and you don't have any questions, then that would be surprising.
Yeah. That's true. One quick question actually. It's
go ahead.
related to the task you're doing today. I was actually having a really, really good time to change the IP addresses for one of the what is called the interfaces of it 1/1 and 1/2. So if you see the difference, the one you working with is just other around. You can see the number of the first one is it 1/2, and
in
the
your
1/1,
pods,
right?
it's the other way around.
Yeah, it's other way around. Yeah,
that's fine. That's okay.
So what happened is I did it like according to the the software that's provided us.
I got it where you're going.
But now I can't see any traffic coming through.
Right.
And I was just scratching my head and stuff, and nothing happened. Change the things, and then the firewall, when I'm trying to commit it, it doesn't allow me to go through. It says that 288.192.1/24 is not a valid IP address. Right. So it took me about like a couple of hours to do that, but couldn't finish the problem, and I had to wipe out everything. So I'm going to start everything from scratch.
But you kind of figured out what the problem was.
No, I couldn't. To be honest with you.
Okay.
No. I was following all the commands that you provided, all the cheat sheet. The only one I found it out trying to change the IP address from the CLI. Still the same problem. So I was thinking to leave it as it is and ask you this question. I said, nah, I'm gonna start it over again, and just go one more time just to rehash everything, see what's going on. But what could be the reason? I couldn't figure it out.
So just make sure. I mean, so it could have been possible that when I put out or replicated the topology, it kind of swapped out the interfaces. Okay. So make sure. So did you set up path monitoring as well? Or it was just...
I followed exactly what you did at previous lessons up to yesterday.
Oh, okay. So I'll tell you what happened. What I'm assuming, since I didn't saw what you did. So I believe what happened was in your topology, these interfaces are swapped out. So this is 1/1, and this is 1/2. All right?
That's correct, yeah.
Now, what happened with this was, technically, in my case, this has a matrix of 10, and this has a matrix of 20. In my case, right? So which prefers this interface for the traffic? Now, when the interfaces in your topology got swapped, these values you configured to be swapped as well. So now when you're trying to send the traffic, you're trying to send the traffic from an inactive interface with respect to the path monitoring. Okay, so that's what really happened. Okay, so when now you try to set up, just ignore my IP addressing and my interface that you see in my lab, okay, and just follow the interfaces in your topology.
Yeah.
Okay, so that you don't mess up the interfaces. Okay. Apart from that, whatever configuration that really go, just follow that based upon the interface numbering and convention that you have in your topology.
Okay.
All right. Make sense?
Yeah. Well, I didn't realize that other round. Like
that's why I asked you if you did the path monitoring. So you said you set up everything up until yesterday. So yes, you did the path monitoring as well.
Yeah. Yeah, the path monitoring, I can't recall that, to be honest with you. But when I was looking at for troubleshooting, the path monitoring things, it didn't come up as an option in my mind.
Yeah.
So maybe when I'm going to be
Again, yes,
reconfiguring
happens.
the
If it's the first time you are configuring a new product, then
yeah.
obviously, I mean, that's absolutely fine.
Yeah. All right.
All right.
Cool. Thanks, man.
Okay. Cool. So let's come back here and talk about the destination NAT. So what the destination NAT is now going to help us do. From this PC, I should be able to access this web server. Okay. Now, obviously, this web server here is running a private IP address. So obviously, I'm not going to publish a public IP address, or sorry, a private IP address, right? So these users would typically access a web page, right, an FQDN. And in production perspective, or from a real world environment perspective, this FQDN, which something could be as simple as Amazon.com, this was resolved to my public IP address. That's really how things work out in the wild. Okay, so Amazon.com has this FQDN in public DNS servers resolving to public IP address that belong to them. Okay, so that when this PC, this client resolves that public IP address and it sends that packet to its ISP, the ISP can do routing, etc., and figure out that, hey, this needs to be routed to this guy here. Now, whoever it could be here, in our case, it's a firewall. Okay, and then this firewall will typically NAT the public IP to public destination IP to the private destination IP and route that packet inside. Okay, so that's what we'll be doing as well. Okay, so in our case, obviously we don't have any FQDN, etc., etc. So what we will do is we'll just use an IP address. Okay, so our WAN has an IP of primary 588.195.1. Okay, or .0 is the subnet, let's say in our case, which belongs to our fictional organization that we have. Okay, so we will say that if 588.195.2 IP address is received over port 80, this should get translated to 10.04.2.80. That's going to be our destination NAT that we will set up. Okay, now there are a couple of things that happen with destination NAT, a couple of different things that happen. The firewall is zone-based. The source and destination zone evaluation that happens, the evaluation happens before the NAT policy is evaluated. Okay, before the NAT policy is evaluated. So when we do inside to outside, when we did the source NAT, okay, the source NATing was determined based on, just give me a second, I've got a call to attend, sorry, just 1 minute. All right, sorry about that. Okay, so in case of inside to outside, the routing and everything happens, the source and destination zones are looked up, and then the NAT policy is seen, and then based on the NAT policy, the translation, everything happens. Okay. In case of destination NAT, you always configure the source and destination zone to be the same. Okay, the source and destination zone will be same. when you would create the NAT policy. The routing table will determine the source zone based on the default route. And the destination zone will be based on the connected network, which is basically configured on this external interface. So since we are trying to come in on this 588.195.0, the connected network is this interface, E11. Right? That's the connected interface. And this is also the source interface because this is where the traffic is coming in. So when you would create a NAT policy in case of destination NAT, right? This is where Palo Alto Firewall is very different than other firewalls, the way that it does destination netting, okay? You would configure the source zone and the destination zone to be WAN P self, both. The same, it's going to be identical. Okay, and then you would say 5.88, if the traffic is received this way, translated to 10.04. Okay, so this is how my policy, NAT policy, will look like.
Bit confusing. Bit confusing.
Yeah, let me just come in here and let me just create the
Okay.
policy, and then it makes a bit more sense. So previously we have a NAT policy created here when we are trying to go from the inside to the internet. We defined our source zone as our LAN, our inside zones. And then the destination zone is our WAN, right? So since we have two ISPs, two WAN links, we have a P and a S, both. Okay. Now when we do destination NAT, okay, and it all lies in the packet flow, the way that the packet flow happens. Since it's a zone-based firewall, source and destination zones are determined first before the NAT policy is evaluated. So from a Palo Alto Firewall's perspective, packet received, source zone is determined. There is a routing lookup that happens through which it determines how the packet will be routed out. So it determines what the egress interface is. And then based on the egress interface, it can figure out what zone it is in the interface. So that way, the destination zone is figured out. And finally, the NAT is applied. Okay, so when the evaluation happens, when the traffic is going from inside to outside, all of this happens before these NAT policies are applied. Okay, so by the time it reaches the NAT evaluation stage, it knows what the source zone is and the destination zone is. So that's why, or that's how it can apply the NAT state. Okay, that's what the flow is. Now, in case of inbound NAT, okay, things are a little different. Okay, let me come here. Okay, so I hope this is understandable, right? Packet comes in, source zone is determined based on what interface the packet came in. Okay, so for example, when I am doing, not sure why my laptop is slow. Okay, never mind. So when I come here, when the packet is initiated from here, it comes in here, comes to the firewall, comes in here. Let's say destination is 8888. Okay, this comes here. So this is coming in on Ethernet 1/3.20. That's a subinterface that we have created, right? So this is the packet on which the packet actually came in. It knows obviously on what interface the packet come in. there's a zone attached to it, which in this case is a slacks zone, right? So it now knows the zone. To route this packet, it looks up its routing table. It sees if this IP address can be routed out of any of its connected interfaces. If not, then it checks the default route. The default route points to an outside interface. Let's say in this case, E11, which is bound to a WAN P zone. Okay, so just like that, it has now figured out the source zone and the destination zone. And now it can evaluate and apply the NAT policy, right? Now when we are doing destination NAT, when he is originating packet, okay? So he is originating packet on, let's say, 586.195.2, for example. Let's say 443. Port information does not really matter, okay? 5.86.195.2.443. Okay, so this device is reaching this IP address, and eventually it needs to reach this IP address. Okay, so now what will happen is, so this PC will have some sort of a IP address as well, right? So this will be a source. This is a destination. Let's say his source is 1111. Could be anything, right? It's something on the public internet. Okay, now when the packet comes in with the source, source with this, destination with this, packet comes to the firewall. Firewall will try to look up this IP address in its routing table. Okay, source, it will always check the source. When packet come in here, it always checks the source. So first step is checking the source. Okay, will not check the destination. So he checks the source. And how is this source reachable? Now, from the firewall's perspective, this would be a public IP address in this case. The only way for him, or for the firewall to reach this is a default route. This default route points to this interface, which is WAN P zone, right? So this becomes the source zone now. Next, we'll look at the destination. This destination belongs to this network, which is again off of E11, which belongs to WAN P zone again, which becomes the destination zone. So now in case of destination NAT, the source zone and the destination zone are the same. That's how the firewall looks up. Okay, and that's why when the NAT policy will now be evaluated. So this is the first step. The packet came in, the source zone was evaluated, the routing lookup was done, destination zone was evaluated. Now it needs to do the NAT. So if you're trying to do NAT policy for destination NAT, the source and the destination zone would need to be same. Only then the destination NAT will be done by the firewall. Because if it will not be able to look any policy. Well, now it makes sense a little bit.
No. Still
Did you
confused.
say yes or no?
No, sorry.
It still did not make sense? Oh,
Nah.
okay.
I'm still confused.
I don't know. I'm still confused. For the source zone that you mentioned, 000 and
Okay,
1111.
so let's circle back again. Let's say this user who is at 10, 0, 20 dot, in our case, it has a 90 IP address. Okay, he initiates traffic to, let's say 8888. Correct? Packet comes to the firewall. Now the firewall needs to, when it receives a packet, it first needs to figure out the source zone, right? This packet comes in on Ethernet 1.20 subinterface that we have created for this VLAN, right? Everyone following at this point, up until this point? Okay.
Yes. Yep.
Now the firewall does a lookup for this source first. How can it reach this source network? It can reach this source network through the Ethernet 1/3.20 network because it's a connected subnet, directly connected subnet. It knows the interface. It can figure out what the zone is, right? So if we come into here, come into zone, let me 1/3.20 belongs to LAN slack zone. Okay. So source zone done. Next, it will do a routing lookup for the destination. What's the destination here? 8888. The firewall sees, is this 888 network part of or belongs to any of its connected networks? It does not. So it needs to do a default routing in our case, right? To the default route, what do we have in our default route? Virtual router, let's come into more runtime stats. Let's look at our forwarding table. Our default route points to this as the next hop, and this is the interface. So the firewall knows that this destination can be sent out of Ethernet 1/1 interface. What's the zone for Ethernet 1/1?
Is it primary?
Correct. It's the WAN P. Okay, so routing lookup, it figured the interface, and then it figured the destination zone as WAN P. So now at the end of this, it knows that the source zone is LAN slacks. The destination zone is WAN P. It can now do the NAT policy evaluation. So if this comes up, let's go into our policy, NAT. It comes to its NAT policies and it sees LAN slacks is the source, WAN P is the destination. The source is coming from VLAN 20, destination is anything. It needs to do a natting and translate this to that interface IP address and do the path. All right, the NAT evaluation happens and the source natting is done. Are we good?
Clear.
That explains the process. Okay.
Yes.
Let's flip this around. Let's now see what happens when the packet comes from the outside. That's what the goal is, right? For destination NAT. That's why the use case is for destination NAT. Okay. Now this guy here has some sort of a source. Okay. And I'm just putting a dummy IP address. Obviously, no one will have a 111, but I'm just putting it in just for the sake of it. Okay. It will be some sort of a public address. Okay. This PC sitting on the outside in the internet somewhere, this would have come from behind a NAT router as well. Its source address would have been translated to, a public address so that its traffic can be sent on the outside, right? That's what really happens. Its destination is, because it's trying to reach server, it will resolve to a public IP which belongs to us, to the organization. Okay, I'm just taking it to be a 195.2. Okay, so taking the fact that this user enters maybe some sort of a website, let's say eretail.com, this resolves to this IP address on its browser, on its machine. Okay, this IP address, public IP address, belongs to us because we host the server. This packet comes into the firewall. What's our flow? Packet, first thing, source zone. The firewall sees source. Is this source part of any of its connected networks? Obviously, it won't be because this packet is coming from the public internet. So how can it reach the source? How is this source reachable? This source can only be reached through a default route from the firewall's perspective. Right? Now, the default route that we had points to, what's the zone?
WAN P.
The source zone becomes WAN P. Correct. Next step is routing lookup. It will check its routing table and see how this destination can be reached. This destination is part of its network that's connected to it, obviously. Okay, that's why this IP address or this packet will reach us or reach my device, which belongs to my organization, if that IP address, that network belongs to me. Right? So it sees that this network for which it's receiving the packet, it belongs to itself. It's one of its connected interfaces, which in this case happens to be Ethernet 1/1, because of which the destination zone becomes WAN P as well. So now that it has figured out source zone and destination zone, it can now go into the NAT policy. And obviously, right now we don't have any NAT rules configured, but then our NAT rule would have both the source zone as WAN P and destination zone as WAN P as well. Okay, and then the source address would typically, in this case, would be something like 5.86.195.2 and translated it to 10.04.2. That will become our destination NAT.
Okay. Arun, I just have one question now.
Mm-hmm.
So when the packet will receive at the WAN P, right?
Right.
Further, when it need to travel to the server 1,
Mm-hmm.
it has already the information for 10.0.4.2.
Correct.
So it can know where it need to go internally,
Correct.
right?
After
that.
NAT.
Yes.
After doing
Okay.
the NAT, then it does the routing actually. This here, it's just a lookup. It is not doing routing at this point. Okay.
Got it.
The only reason for doing the routing lookup is that it can figure out what the interface would be through which it will send the packet out, and then figure out the destination zone. Because again, all the policies and everything that we are creating is based on source and destination zone. So there needs to be a way in which it can figure out those zones. Only then it can apply the policies And later on, when we'll see some of the advanced features, everything is based on zones. Okay, so this is typically the initial packet processing that happens within the Palo firewall. Okay,
Clear
so
now.
after it has done that, NAT is done. It changes the packets, the IP address, then it can do the access policies, etc. And when everything is done, it will then do the routing. Okay, in this case, this network is really just attached to it. Okay, if it's not attached, then you would have some sort of either internal routing where you would maybe running some sort of dynamic routing protocol through which you can send this packet internally somewhere.
Okay.
All right, makes sense? Now it's clear? You understand the difference now, how the source NAT and destination NAT is happening and why the destination NAT has both of those the same, right?
It's a quick basic question here.
Yeah.
We determined that, yes, okay, source and the destination is WNP.
Mm-hmm.
But my question is here, how the firewall will determine this is traffic actually going to 10.0.4.2?
Because we will be creating a NAT policy which will actually translate that into that IP address, the 10.04.2. So we will tell the firewall that if you receive anything with a destination of this and both the zones are the same in that case, you then need to translate this IP address to 10.04.2 and then later on figure out how you can route this. Okay, so we actually tell the firewall to do that translation. We will actually create a NAT policy rule through which it will do the translation.
So this is because we are actually broadcasting our website is on that server.
Absolutely.
That's right, yeah?
Correct.
Okay, all right. If
And
that would
obviously when you're
be on the other server, that could be, the IP address could be 10.5.2.
yeah, absolutely. Could be anything.
Okay.
Okay, so if you have
Wow.
multiple servers, typically, maybe if you try to access something like Amazon would have hundreds of web servers sitting behind maybe a couple of public IP addresses in sort of like a server farm. Okay, so those 2 IP addresses or those 3 IP addresses that Amazon owns, internally, it could be doing anything with that. It could be doing a load balancing, right? Where a load balancer, maybe a couple of load balancers are taking traffic from either of those 3 public IP addresses, and they are equivalently load sharing those across its server farm.
Oh, here I think it's pretty makes sense now, pretty much, because the internal servers, the firewall should know which servers is broadcasting what website. So, for instance, if we have multiple websites, right, and that information should be in the firewall, and if any traffic comes with the header, says that, say, for instance, one of the servers is actually broadcasting Amazon.com.
Mm-hmm.
And then the traffic will come with the header, say www.amazon.com. Then Firewall will understand, okay, this packet's supposed to go to Amazon.com server, and they will send it to that server. Am I right?
So from the firewall's perspective,
From the policy?
NAT happens at layer 3 and layer 4. It is not looking at layer 7.
Okay.
Okay, it's just looking at that layer 3, layer 4 information. It's just looking at that IP address, port information to do the translation. Okay, NAT does not work at layer 7. I mean, it does work at layer 7
Which is the application
for some cases. For example, if I have VoIP traffic, or maybe if I have FTP, okay, some other protocols that carry port information within the layer 7 packets, that's when you typically do NATing in those packets as well, right? For example, RTP packets, which actually carry audio or video, for example, right? Yeah. They carry port information inside of layer 7. So at that point in time, the firewall would typically do the NATing inside of layer 7 as well. We typically call it ALG, an application layer gateway. Okay. In this case, and for most cases, it typically just operates and works at layer 3, layer 4, which it's doing here as well.
So I'm just trying to understand what sort of information the packet will have to actually let the firewall know that I am trying to, or my destination will be actually on one of the servers, which is 4.2.
The destination here. So Yeah, so I could have this set to, let's say, 586.195.2 translate to this, and then 586.195.3 to maybe translate to 10.0.5.2.
Yeah, so the question is here. So you show the 5.86.195.2 is translating to 10.0.0.2.4.2.
Correct.
So this NAT is happening here. My question is, why is going to 4.2, not 5.2?
Because we are manually specifying that. We are just like we did for the source NAT. For destination NAT, we are hard coding a one-to-one policy, which is saying exactly that if you receive a destination of this, you have to translate it to 4.2 and then route the packet to 4.2.
And then why are we sending it to 4.2? I just trying to understand that the piece of information is actually confusing me.
I mean, you could send it to 5.2. You could send it to 99999. You could send it to anyone that you want. Okay. In real world, right? Typically, I would have a load balancer here.
Okay.
Right. And then this load balancer will have a virtual IP, and all of your servers are behind this load balancer. So this public IP would translate to the load balancer's IP, and then load balancer takes care of where it needs to route it internally. That's another way in which you can do that.
Okay. All right. I think that makes sense to me now. Yes.
Right?
Yeah. Yep. Thank you.
Okay. Now that makes sense. Let's see what the NAT policy will really look like. Come in here, do an add. And I'll say internet to DMZ. Okay, and then you can add a description if you want to. I'll come into original packet here. And this way I'll configure the source zone. I'm going to say the source zone belongs to WAN P. It would be. And the destination zone will belong to WAN P as well. Okay, so just that indication here where my source and the destination zones are the same. That is self-explanatory that this configuration is for destination NAT. Okay, so if in the exam or somewhere someone shows you something like this and they are in the NAT policy and they ask you what sort of a NAT it is, you should instantly say it's destination NAT because the source zone and the destination zone are the same. Okay, and then the destination interface will obviously be Ethernet 1.1, which belongs to these zones here. Okay, source address, in this case, the source address could be anything, right? That user sitting on the internet could be at any IP address. Right? And the destination address in this case would be that public address of the server, which in this case we were stating that as, let me just check again. 286.195, or sorry, 586.195.2. Right? That's the destination address that we will receive, that the firewall will receive from the outside. Now, if we go into translated packet, we are not doing anything with source now. We're just doing destination. So I could say in this case, something like static IP and translate it to, you already have the object. I could have written it manually as well. DMZ server 1. And okay. This now becomes my destination NAT. Both my zones are the same. The traffic will be received on that destination interface, that WAN P, which belongs or which is in that WAN P zone. Obviously, source IP address, we won't care because it's coming from the internet. It could be any source. The destination for the packet would be 586.195.2, which belongs to R, or which is owned by the organization. And then for this destination address, I want to translate that to the IP address that belongs to this object, which is 10.0.4.2. And that's how my destination NAT will work. Okay. And since in this case, I have multiple WANs, okay, I would then need to also provision, or I could also provision it for the other WAN if the traffic comes in from the other WAN once this WAN goes down. And then if I also need to do for the other server, I would add another statement here, which would translate maybe same IP address or a different IP address to that 5.2. Okay. And if I have a load balancer, then this public address will get translated to the load balancer's IP address, and that load balancer could have n number of servers behind it. It would be his job to do the load balancing. So you won't really need to worry about any sort of one-to-one mapping in case you have a good number of servers hosted in your environment. Okay, so that typically is how you would do things in production as well, right? Because if you have 5, 10, 15, 20 servers, obviously you would be doing load balancing. Firewall is not something that would do load balancing. It can still do it, but then you would need to do a lot of routing-based manipulation. You would need to do a lot of ECMP. Okay, it's not its job to do that. Okay, load balancer is typically the right solution in that case. The load balancer would come in, you would translate it to its IP address, and then it handles, and it also takes care, and it worries about also which servers are online and which servers to basically send the traffic to and which ones do not. Okay, that's how the configuration really will look like for destination. All right, and in this case, if I also need to do some sort of a port translation, for example, what we were talking about, the port forwarding. Okay, so if I want to do port forwarding, in that case, maybe this server of mine that I have, it's, is listening on port 8443. And then the user from the outside is going to send traffic, obviously, on the common known port 443. In that case, from a translation perspective, I could mention here 8443 as well. So this would now not only translate the IP address from that 586 to 10.04, it will also translate the destination port from whatever it is to 8443. So it's this easy to do port forwarding now as well. Okay, so nothing really out of the box that you need to do to translate the port. Okay, if I leave this blank, then it basically takes whatever the port is coming from the outside. So it does not fiddle or it does not change the ports. Okay, if I need to do dynamic, just like we did for PAT, I could do dynamic IP as well. Okay, if I have a pool, I want to do that, it can do a distribution based on either round robin or hash, lease sessions, etc. Okay, again, this is something that could be done from a load balancing perspective from the firewalls as well. I could have a bunch of addresses in a range. Okay, let's say I have 10 servers, I have 10 IP addresses, I could do 10 different servers, and then I could dynamically have the firewall translate to each one of them based upon a round robin. Okay, or maybe the ones which basically have the least amount of sessions, I could translate to those destination addresses and can kind of do a bit of load balancing through the firewall itself. Okay, so obviously, if let's say I have 2, 3, 4, 5 firewalls, an organization is not going to invest a load balancer separately as well. So this is kind of like a cheap way for you to also do load balancing through the firewall. Okay, very basic, nothing too extraordinary.
So load balancer comes as a hardware form or is a software from it both?
I mean, with respect to Palo or in general?
In general.
You can have an appliance. They can be virtual as well. So for example, a very common one is F5.
Yeah.
Right? They have got their LTM, GTM. They come in appliances, they come in virtual forms.
Okay.
Right? So I'd be cool with the destination NAT, right? So it took a couple of tries to get the message. Do practice it. That's what I'll say. Okay. From the NAT perspective, do make sure that you go through and do the NAT, especially the destination NAT. Okay. Source NAT is very simple, very straightforward. Okay. The only trick behind the destination NAT is just to understand that flow. Packet comes in, source zone is evaluated, routing lookup is done to determine the destination zone or the egress interface. Once the egress interface is figured out, destination zone is figured out. Once the source and destination zones are in place, we can then do the NAT policy evaluation. Okay, so if you keep that at the back of your head, NATing gets very simple. Okay, if you miss either of those, then obviously, once you don't understand the flow, you won't be able to understand how the NATing is really being taken care of by the firewall. Okay. So give that a shot, give it a try, run through the labs, reach out to me in the Discord if there are any problems. Okay.
Yeah. Going back to my original question again, Arun.
Yes.
How you override an IP address that already been assigned to a port?
You're talking from the CLI or from the when you do from the web?
Like
It's
in a
very easy
web,
either
because
ways.
I was not successful. As I was saying, I was like really confused. Like I tried from the GUI, I tried from the CLI. Every single time it was giving me the error. It looks like it's very stubborn and
So what
didn't
was
like
the
it.
error that you were getting?
The error was like it couldn't identify the IP address, which is when I put the IP address other way around, right? So when you replace the or you take the IP address from the primary one, the secondary one becomes the primary one, right? And if you're trying to delete it, it's not going to allow you to delete. So what happened is the secondary one is my primary one, and that was on 586.195.1. And at the same time, I was trying to assign IP address on Ethernet 1/1. The IP address was 2.88.192.1. And then when I was trying to commit it, it says the IP address is invalid. And that was actually very interesting. And then I tried a GUI problem, and I went to CLI, followed the cheat sheet, and found the command is saying network interface Ethernet/1 layer 3 anti-IP address and subnet. Try this way, and then try to commit it, same problem. So I couldn't change actually. So my question is, can it possible actually to change the IP address once we assign already on one port?
Yep.
It doesn't override.
So as you can see, you have assigned an IP address, and then I mean you can go ahead and add. You can add even a second IP address, right? So multiple IP addresses are allowed. Okay. You can assign a different IP address and remove this as well. Okay. The only thing I'm not sure, it could be that it might be detecting an overlap. Okay. So in that case, typically what you can do is you can come in here, delete it.
Did it?
Do an OK. Okay. So delete the IP address completely from both the interfaces. You know, if you have kind of by mistake swapped them, okay, delete it on both of them, commit it.
No, it didn't allow me to. That's the problem. Once I delete the both, and then it gives me error message, and I was not able to do it.
See. It should not. It would be interesting if it does give an error. Let's see.
There you go. It's not an alert keyword.
Oh, okay. Yeah, so
Yes.
it's because it's assigned to the VR, the virtual router. That's why it's not allowing me to do that.
Your information that comes is different than mine. Yeah.
Okay.
But kind of, yeah.
So let's just try this. So let me just pull this off. Do this none here. So that I remove it completely from the virtual router. Remember, cannot be deleted. Routing table, static route. Okay. So the thing is that there are lots of dependencies once we have things set up. Okay. So right now there are, within the virtual router, there are static routes that we have defined as well. Okay. So let's see. Come in here. Let's try to undo some of those dependencies. What I'll do is I'll probably come into static route and trying to remove this one. So delete. Okay. And from the VR, I'll also remove that interface. It's 1, 1, I guess. 1, 2. This one here. Let me remove it from here as well. Okay. Okay, it's no longer present. Let's try that again. There's config, route, autofocus, source is not a valid reference, addresses. So you were getting this error?
Now it was showing the IP address, exactly the IP address. Yeah, so it was saying like it's not a valid IP address.
The address
The
is
first
invalid.
one, yeah, the top one, 2.
It's not a valid
First
reference.
one was
okay.
That was the popping up. Yeah, that's
right.
the one.
I'll tell you why that is happening as well. So, I mean, since you followed the labs up until the point yesterday, so if I'm pretty sure you would have also done the service route. Right? You would have gone into the service, set the service route, right? So you can see everywhere there's a reference. You can see that?
That's right. Yeah.
There's a reference for that IP address everywhere. So now when you're trying to save and remove that IP address, but that IP address is being used by a lot of other services as well. Okay. So if I do that, hit OK. So now I've removed that reference from here as well.
Right.
Okay. So let's give it a try. So it was being referenced by the virtual router, by the static route. Remove that. It was being referenced by that service route. Since we did the service route as well, I removed that reference as well.
Fingers crossed.
I mean, if it still gives the error, it will actually show you where that reference now would be, right? So now you can see it's showing the NAT reference because we also have it configured as part of the NAT.
Okay.
Okay. So once you have configured the firewall already with lots of different things, so that IP address then basically gets referenced because of everywhere we are using either the object or we are using the zones. The zones are tied to the interface, and then the interface are tied to the. So, I mean, this is obviously going to be a little bit of work if you try to do this. A much better way, which I typically recommend when you're trying to do labs and everything, is before you start configuring and make changes, major changes, right? So once you have set up the zones and the interfaces only, no policies, no NAT, no nothing, come in here and create a snapshot.
Just for the backup. Okay.
Correct. Create a snapshot and name it.
That's come in handy.
Okay. Do something like base IP only, something like that.
Yeah, that makes sense.
So that if anything goes bad, you can just go back, load that snapshot, and you don't have to, fiddle through deleting all the references, etc.
Yeah. That makes sense when you're not making any mistake assigning IP address.
Correct, because once you assigned it, and for example, if it's a production box, you would have tons of other things being tied to that IP address now. You might have dynamic routing protocols, VPNs running, etc., etc.
Yeah,
Okay,
handle
so
stuff,
yes,
yeah.
it becomes kind of a headache then. Change that
Yeah.
IP address. Okay,
Yeah.
at least deleting it. Okay, you
Yeah.
could change that IP address in that same place, so that now that
Okay.
IP address gets updated. Okay, because you're not removing the IP address, or you're not removing the interface really. Okay, so that interface is really being referenced everywhere, just in the IP address. That might still be allowed. Okay, but a much better thing is to, before you start working, you set up the IP addresses, the interfaces, zones, etc. Just take a snapshot, save it,
Yeah.
okay, and then start doing things. If you have to revert, just revert to the snapshot, and you're good to go.
You know what? In Cisco, you just type no IP address, bang, done. No IP address, the other one done. You know, so easy.
So again,
And so this one, like if
if
you swap the IP addresses to one to the other, and that's make your life really
I mean,
hard.
even in Cisco firewalls, if you are in a full-fledged firewall configured state, and that interface and IP address is being referenced in tons of other places, it won't let you do the same thing again.
I wouldn't be surprised. Yeah.
Okay, it's
Yes,
just
yes.
to kind of like a fail-safe mechanism to protect
Yeah.
from not doing something foolish and then kind of corrupting the firewall altogether. So
Yes,
anywhere you have references,
Makes sense.
you won't be able to make the changes unless you undo those references, really.
Just going backward, yeah, one by one.
yes. Actually, even I'm trying to delete on the for the FortiGate for the tunnel directly. It won't actually.
I mean, everywhere there are
Everywhere.
references, the objects are being used everywhere, because understand, all of these systems in the backend, they are Linux. Okay, so everywhere there are dependencies, right? So one thing that you define inside of databases, they basically get referenced as entries. So unless you remove all these dependency, it won't let you remove that object from the database completely, because it's being called in other places.
Even
So here,
for the object in address also, it will not remove directly. If
Correct, it will
it
not.
was in the group, so we need to remove for in the group.
Right, you will need to remove it from the group, and then you would be able to remove it from the database completely, or from the firewall completely. Yes. So everywhere that there are references, you first would need to undo the references, and only then you would be able to make the change.
so here comes the golden rule: check twice, act once.
Correct, right.
Correct. Yeah.
All right.
It's good, Hassan,
learning.
that you
Good
ask.
learning.
That you ask, and now we also know that if we encounter this type of errors, we know we need to check twice and act once.
Just read.
Yeah,
Okay,
that's
so
true.
when you so especially so one thing that's good about the Palo Alto firewall, it actually gives you the complete path in the logs. So just when we were doing the commit, it gave you the complete path where that object is being referenced. So it showed me service, route, etc., etc. So within the firewall, you should really be able to go to that path and see where it's being referenced. So it gives that complete path to you. Okay, in something like maybe Cisco or Fortinet and everything, it will just give you an error that this object is being referenced somewhere. Okay, now what that somewhere is, go figure. Okay, especially a nightmare if you inherited the firewall from someone else and you didn't set it up. You have no idea how things are set up, right? Which objects are being referenced where.
Yeah.
Okay, so that becomes a nightmare,
crazy.
especially. If you have set it up, then sure, give me as vague as warnings as possible, and I'll figure out where I reference those IP addresses. Okay,
Yeah, I
so
will tell you that one best reason actually. So I was in a Wipro. So actually, that Wipro will give that security guys will give some bulk IPs need to block on the ransomware or malicious website. We are blocking on that time. Actually, we have given the super submit for the that time actually 0.0.0 that entire that internet should block actually. So
right.
that night guy has been done. So we don't know that where it's the blocking exactly.
Happens all the time.
Yes.
Absolutely.
So, in a great example, I bought a firewall, Fortinet firewall from Japan, right?
Okay.
and it was sort of kind of a different plug, and everything is different. It's not like an Australian standard. So I had to buy that adapter as well. When I plugged it in, I got onto the GUI. I was like, something was done by the previous one, a second hander. That actually freaked me out. I was like, okay, fine. It doesn't worth spending more time on it. I just left it as it is. And I jump onto learning the Palo Alto because I'm pissed off on Fortinet now.
I mean, the thing with secondhand firewalls refurbished is, and typically with these firewalls is, everything is license based. So even if you got refurbished, it pretty much could be possible that licenses have already been expired. And then, to learn, you would need to download a bunch of updates, etc., which not accessible unless you go ahead, get attached to a contract, pay for the updates, licenses, etc. So, I mean, it any which ways comes at a pretty high cost.
Exactly.
Yeah, that's right.
Arun, I just have a last question regarding the DNet
Yes.
that we did, right? So from the external PC to the server, we can see the web page now, right?
Right.
After doing the net
Correct.
policy.
I mean, we didn't
Okay.
test it because my stuff is pretty slow. But yes, I'll show you the configuration. I'll probably test it and show you next week when we start the lab. But then, yeah, if you go ahead and do it in the lab yourself, then yes, you should be able to access the web page, no problem.
Right.
Okay.
So when next week we will connect, I just want to know that.
Yeah, so technically you still won't be able to see the web page. Okay. And I'll leave that as a task if anyone figures it out why that is happening.
Is it certificate or something?
No, not certificate. Something very, very simple. Okay. So if you have understand up until now things how Palo Firewall works, then you would be able to figure it out. If not, we'll discuss it next week. So a task for everyone to scratch their heads, do the labs and figure it out why it's still not accessing it.
You reckon even DeepSeek not be able to find it?
I probably would encourage and motivate. I mean, to if you have spent a little bit of time in configuring the firewall, you will be able to figure out why it's not working.
Yeah,
look at the logs.
that makes sense.
Just a hint. Look at the logs. It'll tell you why it's not working.
Bit of a tricky. Okay. All right.
Okay.
All right.
Yeah. Cool.
Okay.
All right, guys. Cheers. Have a good week.
You too, mate. Thank you.
See you next weekend. Bye-bye.
See ya.